So these video notes cover basic log equations and inequalities. So the first thing to do is remember the definition of a log. So if log, or if b to the power of x is equal to y, then that means the log base b of y is equal to x. And you want to pay careful attention to how that's said. That's log base b of y is equal to x. So the left side is exponential form, and the right side is log form. So to solve log equations, we typically just convert them to exponential form to get rid of the log. So here we have log base 3 of x minus 1 equals 2. So to get rid of the log, we convert to exponential form. So if the log of x minus 1 is 2, then that means that 3 to the power of 2 equals x minus 1. And that's by the definition of log. And then, so that's pretty straightforward. 9 equals x minus 1, so then x equals 10. Second example just has a little bit, we have this 2 in front. So before we convert to exponential form, we're going to divide by 2 on both sides to get rid of that times 2. So then we get 2x minus 2, log of 2x minus 2. Log base 4 of 2x minus 2 equals 3. And converting to exponential form would give us 4 to the third power equals 2x minus 2. 4 to the third power is 64. And from here it's straightforward. If we add 2, we get 66 equals 2x, and x equals 33. So number 3, we have an inequality. Log inequalities are, we solve them, they're not too difficult to solve, but we have to remember at the beginning, if we have a negative log, we can't take the log of a negative number. So we have to start on the assumption that x must be greater than 0, because can't have log of negative. So using that initial assumption, we have to take that into account in our final solution. So converting to exponential form, we're going to get 5 to the power of 2 is, so 5 to the power of 2 is going to be greater than or equal to x. So 25 is greater than x, or x is less than or equal to 25. And notice here the sign switched because I put the 5 squared on the right side instead of the left side. So we have x must be less than 25. X also must be greater than 0. So altogether the solution would be 0 is less than x, which is less than or equal to 25. So this one, we have log of x plus 1 is less than 3. Now you might be thinking, why does that log not have a base? And remember, if it doesn't have a base, that means, if it doesn't have a base written, that means that it's base 10, and it's a common log. So this is really log base 10. And we have to start on the assumption that the inside of the log has to be greater than 0. So x plus 1 must be greater than 0. So x must be greater than negative 1. And then we can convert it to exponential form. So 10 to the third must be greater than x plus 1. That's 1,000. is greater than x plus 1. So then, and I'm going to switch the side now, so x is less than 999. And x is greater than -1. So both of these have to fit in our solution. So we get -1 is less than x. Less than 999. So over here we have equations with two logs. So to solve these equations that have two logs, we're going to use a fact that's similar to when we solve exponentials. So if we have a log on both sides of the equation, so log base b of x equals log base b of y. So if this is true, then x has to equal y. If log of x equals log of y, then x equals y. And same thing for inequalities. So if log base b of x is greater than or less than or greater than or equal to less than or equal to, then x is greater than y or x is less than y. You get the idea. So using this, these equations actually are pretty straightforward to solve them, because we get, so log base 5 of x minus 4 equals log base 5 of 2x. Then all we have to do is say x minus 4 equals 2x. And then we just solve. So subtract x from both sides. We get -4 equals x. And we're done, right? Wrong. Because if we try to plug this number back in, so does log base 5 of -4 minus 4 equal log base 5 of 2 times -4? And it doesn't, because this is log of -8, which does not exist. So this solution is actually extraneous. And the answer here is no solution. So with these two log equations, even with these two log equations, we have to check for extraneous solutions. Here again, the log on both sides, we can ignore it now because it's the same log, and we just solve x squared minus 4 equals 3x. Now, since this is a quadratic equation, then we need to set it equal to 0 to solve. So x squared minus 3x minus 4 equals 0, which factors into x minus 4 times x plus 1. So this gives us solutions of x equals 4 and x equals -1. And then we need to check it. So if we plug in -1 into both sides, you can see on the right side here, so log base 2 of 3 times -1, that doesn't work. We get a negative. No. So x equals -1 is extraneous. And then the other one, log base 2 of, so 4 squared is 16. Does that equal log base 2 of 3 times 4 is 12? And this one does work. Log equals log base 2 of 12. So this one we're happy. So x equals 4 is the only solution. X equals -1 is extraneous. So for these log inequalities, remember for the log inequalities with one log, we had to make sure that the inside of the log was always positive. We have to do the same thing here, but with both logs. So x plus 3 has to be greater than 0, and 2x plus 1 has to be greater than 0. So we start right away by saying x must be greater than -3, and x must be greater than -1/2. Now, since -1/2 is greater than -3, really I just have to use this fact. X has to be greater than -1/2. If it's greater than -1/2, it's also greater than -3. Now, I can solve the inequality. Again, since both the log is on both sides of the equation, I can ignore it. And solving this, we get, I subtract 3 and subtract 2x, then I get -x is greater than -2. Divide by -1, multiply by -1, whatever. We get x is less than 2. So we have in our solution then x is less than 2 and x is greater than -1/2. So we write -1/2 is less than x, which is less than 2. All right, and same idea here. Both of these logs, first of all, must be positive. -5x minus 8 is greater than 0. So this one will give us x must be greater than 8. And this one gives us x must be, oh, this one's, so here I'm going to get -8 -8 is greater than 5x. And then divide by 5. We get x is less than -8/5. Now here, right away, we can see something. We have x has to be greater than 8, and x has to be less than -8/5. This is before even solving it. Can x be greater than 8 and less than -8/5 at the same time? And the answer is no. So this has no solution, because we have reached what we call a contradiction. X cannot be greater than 8 and less than -8/5 at the same time. Fun fact, the way mathematicians draw a contradiction is like this, because it's two arrows butting heads. All right, that's it.